Now we will talk about the derivative of the parametric functions or the parametric equation, because parametric functions are those functions or equation in which x and y are both depend upon some other variable, such as if x is a function of a variable, let's say u, where a is a constant, and y is also depends upon this variable u. In this equation, x and y are both dependent variable and u is an independent variable, but we can find the rate of change of y with respect to x here. These are known as the parametric equations or parametric functions that contain the parametric equation, and we can also use chain rule in order to find the derivative of such type of functions. Here u is known as the parameter because u is independent and is depend upon y is dependent on u and x is also dependent on u. So u is a parameter and x and y are the parametric equations. So the process is pretty much simple as we did earlier, just to find the rate of change of x with respect to u and finding the rate of change of y with respect to u, and then just using the chain rule that dy by dx, that in this case will be we can say dy by du and du by dx. So by using the chain rule, we can find the derivative of the parametric function. So the process is very simple. Let's start with an example. So we have a function such as x is equal to u plus 1 over u and y is equal to u plus 1, and we've asked to find the rate of change of y with respect to x. So the process is really simple. Just we have to find the rate of change of x with respect to u, because u is an independent variable, u is a parameter. So finding the rate of change, u plus 1 over u, this is equal to d by du of u plus d by du of 1 by u. That is, the rate of change of u is equal to 1, and for this we can use the quotient rule, because this is in the form of f of x over g of x. So the square of the function in the denominator, the rate of change of the first function is a constant, so the rate of change of the first function is 0, and the function in the denominator as it is minus the first function, that is the function in the numerator as it is, and then the rate of change of the second function, that is u in the denominator. So du by du is 1, and we will get 1 plus minus 1 over u square, that is 1 minus 1 over u square. So this is the rate of change of x with respect to u. Now we will find the rate of change of y with respect to u. So d by du of y is equal to u plus 1, and rate of change of u and rate of change of the constant function, that is 1, that is 1 plus 0, because the rate of change of 1 is 0. So we'll get the rate of change of y with respect to u is 1. And now we will find dy by dx by using the chain rule. Now using chain rule, we know dy by dx is equal to dy by du into du by dx, putting the value of dy by du, that is equal to 1. Now we have found dx by du, so we can write this as u square minus 1. So now we can find the reciprocal, or we find the inverse, that is du by dx is equal to u square over u square minus 1. This we can use here. So putting value u square minus 1 over u square, eventually dy by dx comes out d u square minus 1 over u square. So this is our answer. This is the rate of change of the function of the parametric functions in the form of the parameter. So this is a very easy example, and this is really easy to find the derivative of parametric functions by using chain rule. We will meet in the next video and we will talk about explicit or implicit functions, and we will see how to find the derivative of such functions. Take care. Goodbye.